you're ready to buy an electric vehicle. But there's one number the car ads won't tell you about. Voltage. Most EVs today use 400-volt systems, but this year, brands like BMW, Kia, Porsche, and even BYD are switching to 800 volts tech. And the difference is huge. So here's the big question, should you buy now or wait? In this video, I'll break down exactly what 800 volt means, why it matters for charging speed, cost, and performance, and whether it's worth holding off on your purchase. Just wait until you see what 800 volts and beyond can do. Most EVs today, like the Tesla Model 3 or Chevy Bolt, operate on 400 volts. But newer platforms are moving to 800 volts or more. Why? Because higher voltage lets you deliver the same power with half the current. That means thinner cables, less heat, and efficient energy transfer. More on that soon. You'll find 800 volt tech in EVs like the Porsche Taycan, Hyundai ioniq 5, and Kia EV6 GT, all capable of charging at up to 350 kilowatts. BMW's Neue Klasse is launching with 800 volt systems for faster charging and greater efficiency. Mercedes-Benz is rolling it out in the electric G-Class, EQG, and updated EQS SUVs. And in China, it's already booming. NIO's ET7, XPeng G9, and BYD Han EV use high-voltage architectures. Some models even charge at 480 kilowatts, reaching 80% in under 15 minutes. The Hyundai ioniq 5 can go from 10 to 80% in just 18 minutes at a 350 kilowatt charger. A Tesla Model Y on a 400-volt platform, that could take 30 to 40 minutes for the same. And Chinese cars like the XPeng G9, they're claiming 5-minute charges for 200 kilometers. That speed matters on long trips or when time is tight, but fast isn't always best. More on that soon. Here's the science. When voltage goes up, current can go down, and that's a big deal. Why? Because electrical losses are caused by resistance, and heat loss increases with the square of the current. That's the I squared R formula. So if you cut the current in half and you get thinner cables, the heat loss drops to more than a quarter. Imagine you're filling a water tank. You can use a big rusty hose with lots of water flowing gently, or a small hose with water pushed really hard. Either way, the tank fills at the same speed. That's your power. But with the smaller hose and higher pressure, there's less water rubbing on the pipe walls. That means less heat and less waste. That's what we do with electricity. Use high voltage so we don't need as much current and waste less energy. With 800 volts you get cooler systems, lighter wiring, and faster power delivery. All without overloading components. Yes, you absolutely can charge an 800 volt EV on a regular EV charger. Most public stations still run at 400 volts or lower. They'll just charge more slowly, and modern 800 volt EVs are designed to be backward compatible. It's like filling a sports car with regular gas. It works fine, just not at max potential, because the charger can't deliver the voltage needed for ultra-fast speeds. Beyond charging, 800 volts boosts performance. It lets the inverter deliver power to motors with less voltage drop, more control, and better cooling. That means faster acceleration, stronger regen braking, and better thermal management. Perfect for high-performance EVs like the Taycan Turbo S or ioniq 5N. But 800 volt tech has downsides too. These systems are more complex and expensive. High-voltage inverters, onboard chargers, and battery management systems all require premium components. Also, not all public chargers support full 800 volt speeds. If you're plugged into a 150 kilowatts unit limited to 400 volts, your ultra-fast EV may be throttled down. And finally, ultra-fast charging adds more battery wear over time. That brings us to the next point. So what should you look for besides just 800 volts on the spec sheet? 1. Peak charge rate. 800 volts doesn't always mean 350 kilowatts. Some cars cap at 230 or even less. 2. Real-world data. Check sources like EV Database or Recurrent for tested charge speeds. 3. Do you really need fast charging every time? Probably not. Fast charging is great for road trips, but daily, not necessary. Just like phones now optimize charging overnight, EVs can slow charge at home to preserve battery health. If you plug in at 10 p.m. and leave at 7 a.m., you can recharge with a lower power setting that's gentler on the cells. It's smart, safe, and just as effective if you're not in a rush. So what comes after 800 volts? Welcome to the world of 900 volt and 1000 volt electric vehicles, already under development. Lucid Motors leads the charge with its 924 volt architecture in the Lucid Air. It delivers over 300 kilowatts of peak charging power and reaches 80% in about 20 minutes. The high voltage also supports the Air's extreme 1111 horsepower output. CATL, the world's largest battery maker, is developing 4C ultra-fast charging packs designed to work at 900 volts and higher. And BYD is expected to roll out its next-gen E-platform with 900+ volt support, aimed at both performance and fast fleet turnover. Going above 800 volts helps reduce heat even further, shorten charge times to under 10 minutes, and prepare EVs for future megawatt-level chargers, especially for heavy-duty and commercial EVs. And here's where things get really interesting, because none of this works without next-gen batteries. If you want to understand how solid-state batteries might supercharge these ultra-high voltage systems, check out our last video. You'll see why charging speed is only half the story. So, should you wait for an 800 volt EV? If you take frequent road trips, care about charge speed, or want a more future-proof EV, it might make sense to wait, especially with new models launching in 2025 from BMW, Kia, BYD, and Lucid. But if you mostly charge at home overnight, and don't mind a slightly longer fast charge once in a while, you're already fine with 400 volts. Remember, slower charging is actually better for your battery. So for daily use, 800 volts might not change much right now. Bottom line, if you're not in a rush to upgrade, it's worth watching how 800 volts and even 1000 volts EVs evolve in the next 12 to 18 months. Would you wait for a high voltage EV, or grab what's available now? Drop your thoughts in the comments. And if you're enjoying deep dives like this one, make sure to subscribe so you don't miss the next big innovation in EV tech. I'm EV Engineering Nexus. See you in the next cycle.